Hi, I'm Michelle Murphy and I'm your instructor for Anatomy and Physiology 2. One of the most common questions I get in this class is what's the best way to learn physiology? So we'll take a look at that here and see a particular technique that we'll go through and we'll practice it in the assignment, and then you'll have a couple more assignments throughout the term that look at this too because it's such a valuable tool. When you took Anatomy and Physiology 1, the Anatomy and Physiology 1 course focused mainly on anatomy. Memorization works for learning anatomy. It's mostly names and they don't change very often. This Anatomy and Physiology 2 course focuses more on physiology. Memorization doesn't work well for physiology. It's about connections between systems, and the connections are always changing. When students study physiology, they tend to focus on individual systems as if they were separated into boxes. Using popular study techniques such as rereading and highlighting the textbook, students try to memorize the systems. Yet in the body, systems are connected. They're not separated into boxes. The function of every system is interconnected with every other system. Therefore, physiology is more complex than anatomy, so memorization of physiology does not work for long-term retention and understanding. So if memorizing doesn't work, what does? Systems thinking models work. In a research survey of graduate level physiology students I conducted, 94% of the students ranked systems thinking as the most effective study technique of 15 listed techniques for retaining physiology information a year into clinical coursework. So what's systems thinking? It's a way of looking at connections. Just like a computer's functions limited without the internet, organs also cannot fully function without a communication with other organs. To understand systems thinking, we'll start at the beginning and add to our models as we learn more. Systems diagrams may appear complex, but they're an extremely valuable tool in your study toolbox, not only for physiology, but for any integrated subject, history, psychology, and many more. To build a systems model, we start with a single concept, such as sleep. Next, we consider the inputs and outputs to the system. The hormone melatonin stimulates sleep. The reticular activating system of the brain stimulates waking, so it inhibits sleep. And that's a systems model. Systems models can also be used to show pathways. Inhaling air increases blood oxygen. Blood oxygen supports metabolism. Metabolism provides energy for the formation of ATP. Another systems model. Adding connections increases the complexity of the model. Metabolism generates carbon dioxide. A buildup of carbon dioxide in the blood inhibits further metabolism. Holding your breath also increases carbon dioxide. But a buildup of carbon dioxide in blood inhibits your ability to hold your breath. It forces you to breathe. For this discussion assignment, we're starting at the beginning. We'll add complexity in future assignments. To complete the assignment, draw a systems model that includes one concept from the list given in the discussion area. Your model must include one concept and two inputs or outputs. Take a picture or scan your model drawing and upload it as an attachment to the discussion area. Include the concept you chose as the title of your post. More than one student can use the same concept only if their inputs and outputs are different. The first student to post a completed map for the concept has priority. Reply to at least two other students by redrawing the other student's model and adding one new input, output, or connection, just one, so others have a chance to add their ideas as well. Upload a picture or scan of the new drawing as a reply to that student's post. Each original map and reply must be different from those of other students. You cannot repeat someone else's work for credit without adding something new. Be sure to help one another out and email me if you have any questions.